Hello, welcome. I'm deciding to make this unscripted video on just how to do a thermal mod that I've found to help on the 2022 and 2023 G14 lineup that I had to do on my 2023 variant due to thermal constraints and wanting to do VBIOS modding. Primarily, it consists of some thermal pads and some PTM7950. It's going to be a long video, but hopefully it all works out well. First thing is to take it all apart. Once you've turned it off, you want to make sure it is shut down. You can see the indicator lights right there. Once the white LEDs have gone out, it should be safe to turn off. There we go. Flip it over. Now we start removing the screws. I have an electric screwdriver. PH1 bit is recommended as to not damage or strip the screws. This screw should never come out. It stays in there, has a washer on the bottom, right there. So, next up, most important next step is to unplug the battery. To do this, you want to, with your fingernail, nothing conductive, make sure you don't have any rings or watches on that could potentially short any of the components in here. You want to take this little metal tab right there, get a little pointer out. Right there, there's a little metal tab. All you gotta do is push it back. Shouldn't pop off, just pops back. And with your fingernail, you can just pry up on one of the corner edges that has the little holes right here. So all you gotta do is, I do it with my fingernail on one side, pops out red to black. Bend the cable away to make sure it doesn't short anything. Now, this is a step that isn't 100% necessary, but I do, just in case as a protection measure, is to then open the laptop while the cable's unplugged, hanging out right there, and I hold the power button for about 10 seconds, give or take, just to drain all of the existing power out of the capacitors on the board, to make sure that you aren't ever going to damage anything. Now, a problem I've noticed with this model, and the 2023, both models, come with liquid metal on the CPU and the GPU on the 2022s and just on the CPU on the 2023 variant. Sometimes, if you're like me, you're using it, you're carrying it in a backpack vertically, that liquid metal begins to pool on one side, causing uneven thermal distribution, and can sometimes cause improper overheating, and can, in the long term, it can damage the dies. So prior to this, I have replaced both of the thermal pastes. This one is running boron nitride, which is KPX paste. And then the other one, this is the one I've tried it on, 2023 variant, has PTM and the thermal pads and the putty already installed in it. So no need to worry there. So now there's no power on the board. Next thing we want to do is remove the battery. To do that, you have to remove the SSD. So take a PH1 still, unscrew the screw on the end of the SSD. This screw you want to keep separate. It's a different length and threading than the case screws. Pops right up, pops right out. No worries there. Wi-Fi cards here, memories here, SSD we just took out, 2 fans, vapor chamber, 2 radiators, battery speakers, top speakers, all the main stuff you'd find in a laptop. There's a screw right here to remove the battery. So we're just going to unscrew that real quick. Keep that separate. That is a different size than all the other screws. A lot of the screws have the same PH1 bit, but use different lengths in threading for the different components, so you want to be very careful. Then gently pull up on the cable and then pick it up by the battery. Then you've successfully removed the entire battery module. I'm going to set that aside. And next up, we're going to remove the memory just to be safe. Pull it on the 2 pins, pops right out. You can set that aside. So, next thing, this is more of the important bits. There is screws at the top of the heatsink, at the bottoms of the fan, and then also the 4 that have to go in a pattern on the actual heatsink module itself. So next, I'm going to remove the corner ones that are used for the heatsink attachment. Different size threading. Be careful with the one back here. There is the display cable running right next to it. Be very careful when removing it not to damage the display cable in any manner. Then also, you have to remember there is another screw that is held in that is the grounding cable for the display cable hooked on the hinge. You also want to unscrew that just to make sure you're not going to tear that off and remove the grounding from the display. So just be very careful. It's a very delicate wire with a very delicate termination. Next up, we're going to remove the fan screws. These come off. Most of these screws are the same length, size, and threading, so it should be fun to interchange these. I don't risk it, but... And then next up are the actual heatsink screws. I've already voided the warranty, as I put KPX in here, but warranty stickers are not invalid if you break them in the United States due to right to repair. So to undo the heatsink, you do screw 1, screw 2, X pattern, screw 3, and then screw 4, then screw 5, screw 6, screw 7, and then screw 8, also in an X pattern. So now all these are loose. They should not come out. You should not try and pull them out. They're captive in there, so leave them as be. Next important thing is to remove both the fan connectors as to not damage or rip either of these. This one's a little bit hard to get to because it's next to the memory module, so I use a little pry tool on my other nail. It should pop right out, like that. Other thing to worry about is the display cable and the camera cable and the infrared and the microphone. These are hooked to these 2 connectors right here. The display one, you should be able to disconnect fairly easily with the pull tab. Pulls right up. And then the camera module can be removed just by pulling outwards, like that. And this cable has a little bit of adhesive, but nothing crazy, and then you could just pull it apart and put it to the side right there while still leaving this part connected, and that part unscrewed, but leave it in there. So, in theory, we should be safe to remove our heatsink module. Now, removing this is a bit of a tricky task because of how it's designed. The fans are separate, as I've broken the adhesive before. But it should come off, and it should look something like that, except you'd have liquid metal there and there. So the fans can go off to the side. These should be cleaned out. You probably won't have this. This is just from when I had to replace a keyboard on here, so don't worry about that. But this is the original thermal putty on the VRM contacts and the VRAM contact. And then this is the boron putty that I used for both the CPU and the GPU. You do got to be very careful not to bend these heat pipes. I do have a very small bend right there that has decreased the performance, but luckily it's still pretty efficient. I should get a new cooler for this, but That was when I first got it, and that was about 4 years ago. So we'll set that off to the side. Be careful as to not damage that either. So cleaning off the dies, what I'd recommend is 90% or greater isopropyl alcohol. I use it in a spray bottle. I don't use the spray bottle, I use it to contain it. And then I also use normal ass cotton swabs. To get this ready, I usually pour a bit of IPA into a medicine cup. These work great. You don't need much, just enough. And start getting your Q-tips ready. So, for the cleaning of the dies, this is one of the more delicate procedures. You want to get one end wet in IPA, drip off some extra, and then you want to slowly but gently circle and get all of the existing paste that is on your CPU and GPU die off. Everybody has their own methods of doing this. I've found kind of circling and then doing the edges and then the center a bit more most effective, but everybody has their own way of going about it. You should be using more than one Q-tip per die, by the way. Both ends, you should still be using more than one. Even though this looks clean, and this is where most people would stop, rightfully so, looks fine. I still go quite a bit further than that, and I get in between the seal on all sides to get all of that extra thermal paste out, because these were originally designed for liquid metal. To get all of that out right there. And then you can also use something plastic, but thin and gently, a little pry tool to just get in along the edges, just kind of push up some of that extra thermal paste that is stuck in that little ridge right there. And that can more easily help you remove it, like that. You do not want to apply too much pressure, just enough to be able to get it out and away from the die. It's fine if there's still a little bit of residue, it's non-conductive, this paste is. If you're dealing with the original liquid metal in this machine, it is a very different procedure. I would watch a very different video explaining how to remove that safely, because that is a beast in of itself. Because that is electrically conductive, and even if a small drop gets on any of these contacts, the entire board could be dead and shorted out. So you got to be very careful when you're dealing with the original liquid metal in these machines. I've already removed that, luckily, very carefully. Best recommendation is to cover all the sides with tape and then paper to make sure that none of it can get anywhere, and then doing it isopropyl Q-tip by Q-tip, just to make sure you got it all. There are other ways to do it, other methods, but that's the way I've found to be the most effective and most efficient. And even with a clean die like this, it looks pretty darn clean compared to that. I still go quite a bit more until you get a nice little squeak off the die and the Q-tips come back clean without any residue on them. Now, if your CPU has some slight discoloration, like that, I don't know if you can see it in the camera or not, but if it has some slight discoloration on the die, that is okay. That's not actual damage to the silicon. It won't affect your thermals by any marginable amount. It will look like your die is damaged. It is not. It is just leftover oxidization and residue from the original liquid metal. Now the other thing is you can remove this entire board and do this procedure outside, and you have to disconnect all these cables. I personally don't feel like going through all that hassle. I did that with my other one. That was because I was doing a keyboard replacement, a trackpad replacement, battery replacement, a memory replacement upgrade, SSD replacement, Wi-Fi card, and overall cleaning and redoing everything. So if you're doing that, then it's kind of worth it just to take out the entire board and deal with the board while it's out. But if you're just doing thermal mod like this, should be fine to leave it in and just be careful around all the components that are plugged in. And again, the entirety of the power system is removed. There's no battery, there's nothing plugged in, so nothing can actually be shorted. You just have to make sure nothing is bridged when you connect it back together. Again, we're going to give it some light pressure, very light pressure, just around the die, just to break up some of that putty or paste originally that's been on here. Just to coerce it to maybe get a little bit more out. And no die is ever going to be perfectly clean, but you can get it damn near close if you try hard enough. And even now, after all these years, I'm still picking up very, very trace amounts of gallium that was in here from when I got it. So even now, you still got to be very careful as to not get it onto the board itself and to short and damage any components. Also, this die does appear to have less, but still some noticeable oxidization marks from when there was liquid metal on the CPU, or on the GPU. So just keep that in mind. It will look like it's damaged in a way. It's not purely aesthetic. So there we go. Now we have both of the dies perfectly cleaned. Do not touch these with your fingers. Finger oils can interfere with the thermal performance. Next up, we're going to be working on the cooler. Set that off to the side and bring in the cooler. So we're not done with the board yet, but we're on the right path. So this is the cooler. There is all the putty on here. This is what we're going to have to clean off on the board in a bit. This is the CPU and GPU containment fields and the contact plates right there. There is also some discoloration on the GPU that's pretty darn noticeable, but we're going to ignore it because once we clean it off, it should come right off. So yeah, that comes right off of there. No worries. Another thing to keep in mind with the 2022s and 2023s, the keyboards and trackpads are 100% interchangeable, along with the speakers, along with the hinge assemblies, along with the fans, along with a lot of other components. Genuinely, they have a lot in common. Even the bottom plates are the same. The chassis are the same. A lot of components are very similar. But one major, and I mean major difference between the two is the cooler. The 2022 has this contact plate for the GPU, whereas the 2023 is straight up to the copper vapor chamber cooler. So just keep that in mind. You cannot interchange the coolers on these models. Again, not going to be perfect, but be damn near close. Get it as clean and squeaky as you can. As you can see here, there's some gray on the Q-tip. That means there's residue of liquid metal, which you have to be very careful around as to not damage or drip onto any of the components on the board. So just keep that in mind. Because even after the years and years that I've been using this thing without liquid metal, and I've cleaned it, I don't know, about 5 or 6 times, there's still going to be very trace, small residual amounts of gallium inside the cooler, inside the CPU containment field, a lot of different places that you would never expect. So just keep that in mind. When it's about that clear, when you can barely spot a difference, it should be good enough to move on to the next die area. So should be good. Now, I have noticed that on my CPU side, there's a little bit of liquid metal inside of the foam containment field, and you can see a lot of gray coming off. So it gets gray. I recommend using the white side again to make sure that you're not spreading that liquid metal any further than you have to get it all cleaned up. Even that's already gray, so don't be afraid to use more Q-tips. Get a big pack and it'll last you a couple replacements. Now, the CPU does appear to have the plate. The CPU plate appears to have more oxidization than the GPU plate. I've also noticed this on the 2023. CPU plate just appears to oxidize more for some genuinely unknown reason to me. If somebody knows, you can write it down in the comments, but completely foreign to me why it only happens on the CPU side, not the GPU side. And also to note, the only liquid metal that has ever been in this laptop has been the stuff applied from the factory. The reason I thought it was happening on my 2023 was because I reapplied it with Der Bauer's Conductinaut Extreme, but could be wrong. Could just be a genuine oxidization problem with the metal that they used for these dies, or the contact plates, so could be completely out of my ballpark there. Now there is a very small amount of liquid metal right there. Little drop right there. I don't know if you can see that little glistening right there, and then also a little bit inside of the field, inside the containment field. So there's a little bit right there. Gotta be very careful with it. So I usually get my Q-tip wet and completely brush it away safely. Now on the CPU side, because of how much oxidization there is, we're going to need to really scrub. You can see black line forming right there just because of how much oxidization and extra corrosion is coming off. Mainly I did this mod on the 2023 variant as to allow me to modify the NVIDIA VBIOS and enable me to run a 175 watt VBIOS, which it does run quite well at 175 watts, but it cannot sustain that even with all of these mods, just due to the sheer constraints of the size of the cooler and the size of the laptop. There's not enough thermal mass to dissipate that amount of heat, but it can sustain around 150 to 160 watts in my experiences, which does help with performance. So with these thermal putty placement right here, we're going to want to remove all of this, and then also we're going to want to remove where that goes onto the board as well, and cleaning those components is very tedious, I will say. But I'm just gonna use a flat-headed bit right here. You can get these little pry tools all over. And then on the board, that's a completely different story. But once we clean it with this, then we're going to use isopropyl alcohol to clean it fully. So should scrape up pretty darn easily. Also, do not apply too much pressure, just enough pressure in order to get the putty up. You don't want to dent or damage the actual heatsink vapor chamber itself. Although there are supporting structures inside, that's where most of these dots are. The minimal you can impact that, the better. There's also a very small amount on this side, which does some of the VRMs for the GPU, I believe. I'm not entirely sure what this circuit over here does. Could be a voltage rail, could be completely something else, but... And then this also ties along with that, pretty darn sure. And this is the VRAM. There's 8 gigs of VRAM. This is a 6700S variant. So still is 8 gigs of VRAM, just like the 6800S, just a little bit less powerful. Also, way better when you can get it on a $1,000 budget, especially when it was on sale when I got it back in 2022. So I say it was worth it. And these are the CPU VRMs. I don't know why, but they decided to add a split right here, so get out as much as you can from in between there. That's also better. Again, it's not going to be perfect, but get it as best as you can. You can always go back with alcohol and clean off any excess later on, so doesn't need to be perfect. It looks about good enough for now. I mean, there's, you know, obviously going to be a little bit left, but mostly pretty darn good. And then you just want to remove big blob of this stuff. You can see how much dirt this stuff accumulates over the years inside of a laptop even. Kind of disgusting, but and then we're just going to throw that off to the side. Don't want to use that anymore. So next up, we're going to clean all the spots that had that with isopropyl alcohol. You know, gotta go extremely hard on anything, just enough to get all of the residue off of the heat pipes, off of the actual heatsink itself, off of the contact plates, and the other components surrounding it. So this sometimes involves quite a few Q-tips, just to keep in mind. Also, there is probably going to be some very small metal scratches just from using the plastic tool, but most of that will be negligible once we apply new thermal putty on all of the VRMs and the VRM contact plates, so it should be all good. Also, another thing is sometimes dirt does accumulate underneath these contact plates, so if you can go around them, also helps out clean all that area. In the hard to reach places, you also want to clean as best as you can, just to get as much out. Over the years, these parts do just get dirty and dusty, and also some of the dark gray is just some of the paint that was used on the coating on the outside of this to make it look cool with the design, with the graphic on it. Some of that will come off, but as long as you have the main decal facing down, it won't be a noticeable change externally facing. And then with that, you should about have a clean looking cooler with minimal to no residue left from any of the thermal putty. Doesn't hurt to just go over it all once again with the clean Q-tip with some IPA on it just to double check and make sure, but should be most of the residue gone and removed. That should be pretty much what you're looking at. There's a little bit left. There we go. So it should be about good for the cooler side. So it should be pretty damn clean looking. Obviously you can see the corrosion. I don't know if the camera can pick it up, but you can probably see the corrosion on the CPU plate. But overall, turned out pretty good, got all of the main residue off of all of the contact points with the board, and all the VRMs and other components, so pretty good. Also be sure never to touch any of the contact points, as that can produce oils and you don't want that. So we're going to bring the laptop body back over. Make sure not to pinch or crush the display cable. Keep that separate. And next we're going to work on cleaning all of the VRM components, such as these for the GPU, these for the CPU. These are the VRM components. Each of these modules has thermal putty on it. And then there's also just a little bit over on this module right there. So my 2023 had a lot more residue on it. This is honestly minimal compared to my 2023, so not too bad. Should be pretty easy to clean. Sorry for the bad lighting and angle. I'm left-handed, and my desk is kind of in the wrong orientation to record the other way, so not the best angle, but you get the point. Use the thermal putty from before, just kind of wipe on whatever the new stuff is. Put that off to the side. We're not using it anymore, we're just using it as a catch-all. Same with the VRM chips, so we want to get as much of this putty off as possible. These modules you want to be very careful with, just to not damage them. We're also going to clean these with isopropyl alcohol once we get the majority of the paste cleared off, but we first want to just start out with getting the excess paste off, or putty off, and then using a bit of isopropyl alcohol and Q-tips to clean the rest of the VRMs off. The main thing is just to get the majority putty off. Obviously you're never going to be able to get every particulate off, but as long as you get the good amount on the top where the contact is going to be made, should be all good. Again, do not use anything below 90% IPA for this, as if there's any moisture content in it, it can be stuck, trapped, and not fully evaporated by the time you power on the board and cause irreversible damage to the components on the board. So just keep that in mind. Do not be afraid to use more than 100 Q-tips, by the way. This usually takes quite a few, so keep that in mind. These are driver MOSFETs right here, and then these are the VRM packages. There we go. Also, you want to be very careful while cleaning all these components as to not tear up any of the capacitors near there. Just keep that in mind. I usually go back and clean the VRM packets again once I get the majority of the oils off from the putty. looks about good, I'd say. I mean, it's not perfect, but close to it. Yeah, nobody's really going to be seeing the inside components, so you don't have too much to worry about, but don't forget about this little voltage regulator module over here. You also want to clean that off carefully. As carefully as you can. So, should be about a fully clean board and VRM components. Obviously, there's going to be some stuck in between some of the voltage regulator modules, like right here, there's like a little bit just stuck in between, and there's also a little bit stuck in between there, but can't really do too much with that. It's stuck in there, it's not going to harm anything. If anything, it produces better thermal conductivity between different components. So, the next part of this is going to be applying new thermal paste, or a thermal putty, for that matter. So I got, move this off to the side. So I got this stuff, Putty Advanced. There's Putty Extreme, it's about the same, doesn't really matter what you get. I've used the Putty Advanced on 2023. I've never had problems. Comes in a little tube like this, and there's a good amount of putty in there. This is more than enough for multiple G14, so no worries there. And then it comes with some application tools, so I'll just grab 2 of these. Shouldn't need more than 2. If you do, I don't blame you. This stuff is a pain to work with, but 2 should suit you, as long as you also have some of these little tools right here. Also, when you're going from old putty to new putty, you want to clean this off as best as you can, so get all that old stuff off. And what I do is I just take the end of a Q-tip that I haven't used yet, and I just kind of wipe off all the old oils, just to double verify that I'm not going to be cross-contaminating any of the thermal putty. So, should be all good there. Making sure that the cable's out of the way. Put this down. So, dealing with this stuff, I will say it is a pain to deal with, but basically you can grab a little dollop like that, and then this stuff you can kind of shape with your fingers to whatever shape you need, and place it on the component you're trying to deal with. Now, should I be touching it? Probably not, but I haven't really had a problem. This stuff is so damn effective, especially when you clean your fingers before. Should be good. And it's also just a lot easier to deal with the amounts and stuff when you're dealing with it with your fingers. Is that too much? Honestly, probably. I really don't care that much. Any of the excess will just kind of be squeezed off onto the edges of the board. It's not conductive, it's boron based, so should be more than fine. You can also use a tool to spread it out. That's what I did last time, but I will say it took literal hours, and I don't feel like doing all that. So you can use a tool to spread it out and whatever, and get it to the edges of the actual components. I'll probably do that at some point, but for now, we're just gonna let it be and just put a healthy amount on there and just hope that it goes well, because I don't have that much time to do this. So right there. If you do have any unevaporated IPA, make sure that it is fully evaporated before you apply the stuff, or else it will be very difficult to stick the thermal putty onto the components. Keep that in mind. Also, I'm trying to use about an equal amount. Obviously, it's never going to be exact, but as equal as you can get with, just eyeballing it. There we go. Should be a thin application. You do not want a thick, uneven application over the components, but you should no longer be able to see the edges of the component you're working on, or the corners if you can help it. I mean, obviously, to some extent, it's not going to be perfect, but as good as you can get is as good as you can get. So there's a little bit of overshoot right there. Damn it. About like that. Sometimes this putty likes to move around. Also, your fingers will be blue. That's kind of a given at this point, so just be careful what you touch while you're working on this part, but as long as you can spread it out to the corners, you should be all good. That on the side. Sometimes it'll tear. To help it along as best as you can. Back into the right place. Cover up all the components. So it's not a perfect application, but should be close enough for what I'm trying to do right now. Also, this is not the highest powered one. The 2023 I had to be a lot more meticulous due to like any skin oils getting into it, but 2022 they are not nearly as high of a wattage, so you shouldn't have as much of a margin to have problems with it. Next up, we're going to be working on this little guy right here. You want a very, very tiny amount. And I mean, like, this is even too much, probably. I think small amounts of this stuff is, like, insanely difficult. And also, small usable amounts is the other key part of that. Something like this might have to do. Very small amount. Roll it into a little ball. Shit. And then stick it on there. In theory, that should be enough. I could add a bit more, but damn, I wish I had a magnifying scope to do this. Better be safe than sorry, but I'll add a small extra dollop on there just to be safe and not have to worry about it, but something about that big. Not too big, not too small. Looks about good. Good enough for cooling on that side. So then the other part of this, when you, like, I'm not going to put it on, but to line it up, it's going to be hitting that. And then also there's this piece right here, which means that it's going to be coming down into it and try and cool the components near it, which would most likely be this IC right there. So we are going to take a bit more of this putty and put it onto that IC right there. Yeah. Right about like that. Come on. Come on. The other thing that you could do is put it on the cooler side, and when you put the cooler on, it'll smush it all together. It won't really matter anyways, but I try and get it as close as I can to the actual components, just to make everything a bit more precise, a bit more easier. The other thing I like to do is on the side of all of the components I already put thermal putty on, I like to scrape up extra in order to make sure it's all on top of the actual components. And none of it is going to be on the sides when I first put the cooler on, which sometimes can be a mistake, but most of the time it's worth it, just to make sure that all the components are equally getting properly covered in putty. Now right now, during the great shortage of memory of all kinds, DRAM, normal RAM, VRAM, you want to be very careful with your memory packets and make sure they're properly cooled, especially if you're doing any kind of overclocking to get better performance out of your existing memory packets. So just keep that in mind. So now I know I probably could have made this video a few years ago when I originally did my 2023, which is right over in the corner here. But better late than never, not gonna lie. Thought it was decent time to upload. So next up we have the GPU VRMs and the CPU VRMs, which is a beast in of itself. The best way I've found is either to do a dot, like a little ball of it on each individual VRM, or to roll it like a little stick and then put it across all of the components, so I don't gotta worry about the individual components. We got it on there, so now we can kind of start sliding this around a bit. If we need to add more, we can always add more, but I'm gonna get a good base application in first, not mess it up as much as you can. Should be good enough, and obviously going to get some blue hands from all that, but should make proper contact with the VRMs at this point. You are obviously going to waste some, that's just part of the fun of all this. once all of this is pressed down by the heatsink, it will make better contact no matter what. Any existing oils that you left on it from just touching it and stuff are still going to be there. It's going to impact your thermals, but by a fraction of a degree. It's not going to be noticeable from anything that I've tested. So, should be all good. Next up are these components. I say these are the worst because they're all individual, they're all small, they're all in a line, which you wish you could do this, but it's not really that easy. And there we go. Should be good enough to get sustained enough performance for what I'm trying to do. Next part is to apply PTM. This is Phase Sheet PTM 50x40. I've already used some on some other devices from Thermal Grizzly. It's PTM7950. Comes in a little box like this. Take that off. Got some foam right there. And that's the actual PTM7950 sheets. I've cut some up and used some, so don't worry, yours won't come prepackaged like this. I am going to have to apply a very thin line of it right there because this piece I cut for a Snapdragon 888 Plus is not big enough. You shouldn't easily be able to see from any angle the reflectiveness of the die. Next up, we're going to want to install the cooler, which you should not have touched either of these components right here, or any of these components for that matter. You don't have to. I usually lift it by the bottom like this, transport it, clean off any of the dust that is accumulated on here, and then also blow out the radiators just to verify that they are all clear looking, just to make sure that all the dust is out. Put the fans back in. Next up is the actual heatsink. It goes in at an angle like this at first, and you push it back in, making sure not to pinch this cable. And then in theory, it should lower in just like that. You'll hear 2 clicks with the parts on the side. And now it is time to start screwing the heatsink back in. Now, this is where it gets a little bit difficult. You want to do this in the X pattern, but you don't want to screw them in fully when you're doing this. You want to start your first screw, start your second screw, start your third screw, start your fourth screw, start your fifth screw, start your sixth screw, start your seventh screw, start your eighth screw, go back to first, back to second, back to third, back to fourth, doesn't matter, fifth, sixth, seventh, eighth, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. You'll start feeling some resistance, but they're not tight. When they're tight, they should bottom out. So as soon as you start feeling resistance, I back off. And I go to the next screw. And this should be our final tightening phase, so it should fully lock out. You don't want to put too much pressure on them. You don't want to strip them, but you want to make sure that they're properly seated in there firmly. So now our heatsink is back in. Next up, we're going to want to plug back in our fan connectors. Should just pop right in with your net, or even just your finger. What I just did, they pop right back in, so no worries there. Next up, our display cable. Now sometimes this one can be a problem / pain in the ass. If you don't remember to put it underneath this guard, which I forgot, while you're putting the heatsink back in, don't try and squeeze it and pinch it down there. Move this screw, this pops right up like that. You can then route your cable underneath there safely, securely, push this back down without pinching anything, and then put your screw back in. This is the safest method that I've found to properly reinstall the hinge. Next up is a connector for the display. So it routes through there, around this hole. You do not want it over this hole. And then the screen connector should be able to plug in. Just kind of snaps down like that. Shouldn't wiggle too much. And then the next thing is the camera. The infrared sensor and the main FHD front cam should be able to plug in right into the slot right here. You gotta use your fingernail sometimes on the edges just to make sure that it goes in fully, but it should seat in there, and then you can just put the tape back over it, and then this tape hooks right there. Mine's all worn out because I've done this so many times, but as long as it's in, it should be all good. Next up, I have 40 gigs of memory in here. This is a 32 gig DDR5 4800. It's all these can run at anyways, so 32 gig stick and then 8 gig soldered. It does work at 40 gigs of capacity. It's not really rated up to that, but it does work. The other thing I've found with the 2023 is you can put a 48 gig stick in there with 16 gig soldered, and you can get up to 64 gigs. You won't have dual channel, same with this, no dual channel, but you'll have the extra capacity, especially if you need it like for the applications that I use, AI acceleration, video editing, gaming, everything in between just works, which is what's great. So next up, we're going to get into the thermal modding part of this, which is the thermal pads I picked up. I'd recommend 2 to 2.5. I got 3, is what I had on hand. 3 works. 12.8 watts per millikelvin. The highest ones I could find on Amazon. I have, I think it's a 2.5 in the G14. They only had the 3 when I bought these, so no real big concerns there, but I put the 3s in my friend's and it worked out fine for him, so these are a bit thick at 3 mil. I'd recommend getting 2 mil if I were you. But 2 to 2.5. But these thermal pads are 12.8 watts per millikelvin. They're not gonna magically give you all the headroom in the world for cooling, but they will give you more headroom than what this was originally designed with. As the whole point of my thought of doing this is to allow for the heat from the vapor chamber to be transferred into here, obviously inefficiently due to the amount of paint that they put on the 2022s. On the 2023s, it's a bit better, but then into the actual back contact plate. So these have to be cut very specifically to the size of the back plate and to also contact this plate, and also to make sure that you're not covering any vital components, but you do use this back plate as a 5th kind of radiator for this thing, which does help with thermals quite a bit. Downsides to this is this bottom will get very hot, and by very hot I mean you can burn your hand on the back of this metal plate that Asus put on the back of here. That's probably why they never did this. But the benefit is you do not have to run the fan nearly as often, which saves the fan bearings quite a bit. And then also for silent workloads, like if you're attending college or school or any place like that, or in the library, you do not have to run the fans and have that whooshing air. And then also you can play a lot more games without ever activating the fans, just dissipated by this. But when you do this, I would not recommend ever putting your laptop on any soft surface, at least while you have this mod installed, as it can be a thermal hazard, is really what I can say. So sizing these is not the easiest bit, I will say, but you can take a look at the back plate as a reference point. These are where the screws are, where the rubber parts are, so you know to avoid this part, this part, this part, and all these parts. So I do have to stay below the top of the Radeon logo, I'm pretty sure, the Radeon square, and then the Ryzen chip I can go pretty much all around here, and then you'll also want to get the middle if you can. And then also down here and up here where the VRMs are, but these VRMs are locked off because that's where the plastic starts, so you have to be very careful as to where the plastic is starting and where it's ending. And then also you got to be careful where these standoffs are, as to not put anything in this vicinity, and then also on the edges where these points are. Last time I did it, I'm pretty sure I just did the CPU and the GPU, as it was the easiest. So I could go up to about there with the GPU pads, so we can kind of mark that. So if we, let's say, cut this in half, so one of these can be used on the GPU side. I recommend using this side on the actual vapor chamber, as it is. So you might deform it while cutting it, so just kind of push it back into place. But you can face this down and then adjust it to where it shouldn't interfere with the contact of the screws. So you should be able to unscrew it still if you had to, and then also not contact where the plastic is on the framing right here. So you have that screw there, a little bit of plastic there. It's right by the screws, so right above this screw contact. It's right where this ends, so I should be, in theory, pretty darn good right here. And then I just removed the plastic cover, so that's all good. And for the CPU, it's a bit easier, but also a bit more difficult, just because of how they design this. You want to make sure that you're covering the majority of what you can. So I say I'd cut it off right about there, right before the screws. Cover the bottom screws and just right about there. So the pad. Again, you should be able to remove the screws if you have to, so make sure it's oriented in a way where you can easily get at the screws if you had to. I like to put it down just a little bit extra just in case. There we go. And then for the final strip, I'm planning on placing it right in between all of, I mean, you have two options. You could do the VRMs down here, or you could do in between the CPU and the GPU. The thing about the in between the CPU and GPU thing is you gotta be very careful as to where the dots are on the frame right here. So if you put this in, none of the dots are going to be able to contact your components, which is actually very difficult to line up. So just keeping that in mind. The way mine is right now, in theory, I should be able to, if I just kind of scoot this over a little bit. Even if I did a diagonal, I should be good, because screw, so here I should be chilling here. Like that. And then we have to reinstall the battery. So we take our battery pack, being careful not to bend it, put it in. Just like that. And then we're going to start reinstalling all the screws. Next up, put in your SSD. I'm using the stock heatsink on a SSD to run it, so throw that in. You can also install a new Wi-Fi card here if you want to. I have an Intel X210, but I'm saving that for my other laptop, so not too bad. And this is the scary part, and see if you've successfully completed this or you've killed your entire thing. The way I connect this connector, which a lot of people have had problems with this connector, I go from the ground to the positive. So when I put it in, I push it to the ground side first, then I push down on the red side so that all of the voltage going in can be properly drained. If it starts to sizzle or spark, you know you have a problem. But if it just goes in properly the first try, you should be all good. Put on your back cover. Then pray to God that it turns on. Now, sometimes when the battery is disconnected, it will not turn on. Or sometimes it will. Let's see if it works. Sometimes, yeah, it's doing a memory check right now because I took out the memory and reinstalled it. But if the keyboard backlight turns on, which it has, I don't know if you can really see that well at all, but the keyboard backlight has turned on and the power LED is turned on, so should be in the clear. If the keyboard light turns on and then off, or same with the power LED, then you know you have a problem, but as long as both are on and staying on, you should be all good. It may take a hot minute, especially with how much memory I have in this 40 gigs. Memory training can take a while, so. And we have boot. As you can tell, it takes a hot minute to train 40 gigs of memory, but we are booting onto the SSD into Windows 11. So the repair was, at least as of now we know, the board is not dead and it was mostly successful. And we're able to check our temps. See if all was well. Boot up process with no fans, we're at 48, it was at 55, so 48, GPU at 44, idling around there, so not too bad, not too bad at all, especially while it's still in the boot up process. It'll be easier for you to see it this way, but I don't know if you'll be able to make out the numbers and whatnot, but you'll have to take my word for it. It's 49, 45, 0 RPM during just boot up, and the CPU is consuming 8.17, 6.0, 5.3. The temp should be dropping. Temps are going down a little bit. It's idling down. But with no fans, the heat doesn't really have too many places to go. So there now we should have better cooling than before. And once it idles down to normal, especially when you have the dedicated graphics card off, you should be getting way better temps than the stock liquid metal if it runs, which I've had major problems with. So now that we know it turns on, safe to close and rescrew in the entire bottom. Now, already, even from just turning it on, this bottom panel is already getting hot. That is to be expected. The fans are not running because this is taking away a lot of the heat. Be warned, this bottom plate, especially near the center, in between the fans where you put the thermal pads, will get very, very hot. So just be mindful of that, especially if you use this in a lot of places where there's different materials underneath it. Make sure that it's fine with getting that hot. The other thing to note is that if you have the 3mm, I don't know if you're even able to tell, the 3mm is a little bit thicker, so it will start to bow that bottom metal just a teensy bit. If you do a 2.5mm or even a 2mm should be enough to make contact. I do 3 just to make sure there's extra pressure and contact on this part, and then when you do that, just make sure these 3 screws are like extra torqued down, not stripped, just torqued down enough to make sure that there's enough pressure and tight. You shouldn't have any clicking. Again, always use a PH1 bit. That's the only bit you need to repair anything on this laptop aside from the keyboard. That's when you need a PH0, but for the most part it should just be a PH1, and you should have way better performance, way better temps, and overall a much better gaming experience. And this works on both the 2022 and 2023 variants of the G14. I did it on my friend's 2022. I'm just doing it now on my 2022. And I've had it done on my 2023 for a long while. Never have had any problems. My thermals have always been stable. And now that we're actually idled into Windows, we're sitting with still 0 fans and down to 41 and 39C with both the graphics card and the CPU powered on. And over time, sometimes it'll get better, sometimes it'll get worse, depending on what workloads, what Windows feels like doing, because obviously Windows is just Windows on top of whatever you're running. And I got 3 main applications on right now. I got ghelper, I got task manager, and I got HW info, just to kind of monitor all the stats. So not too bad. And the temps are already going down even more. So thank you for watching. Much appreciated. I really hope this video you find is helpful to what you're trying to do with your G14. If you have any questions, feel free to reach out. But have a great rest of your day.